Alright, and we're live. Hello, welcome to stream. Alright, so today, first off, I'm going to be fixing something that was bothering me. Right now my operator overloading, for some reason, I chose to use the keywords binary and unary to say the number of arguments in the expression, but that doesn't really matter because you already have the number of arguments over here, so it's really redundant. So I'm just going to have it say operator, just like it is in, C and C++. So I'm going to first fix all of those. And then after that, what we're going to do is actually implement structs so that I can get things like strings working. I already wrote the string module and most of like a basic struct. But obviously this doesn't work because it doesn't actually generate a struct. It just ignores that because there's no code yet for it. So instead of binary and unary, it's just going to be operator. So now instead of binary and unary, it's just going to be case operator keyword. That was wrong. Whoa, I had no idea you could do that. It deletes until the end of the brace. Is it that? Nope. Whatever. And I think that should fix it. So let's try that out. Oh, no, hold on. I have to take into account the number of arguments, so I have to count that. And I think that's in... Actually, I'm not entirely sure where that happens. So let's just see where the error brings us. I thought I had individual code gen functions. Oh, you know what? I probably do. Yeah, because this is an operator keyword, and then that just gets grouped with the actual operator, but it's not actually... doesn't generate the operator overload. That's just popped off of the stack during function generation, which is here. Let's see. Huh, okay. I don't seem to have a check for that type of node specifically. Yeah, let's just see what the output AST looks like. Build times really are not getting any better. You know, it should be technically possible to create an ASA compiler inside of ASA relatively soon, actually. At least for the front end, that is. I'm not entirely sure how I'm going to handle external things like LVM. I would need to create some kind of translation because LVM by default gives you C++ header files, but obviously those don't work in ASA. So that would probably actually be a lot of work. But you could make a front end, which wouldn't be able to do anything other than output an AST. Oh, right. Hold on. I need to change all of these as well. It's up here. To be operator. And I also need to spell operator correctly. Not really sure where the big lag spikes are coming from in NeoVim. .984. Hmm. Eight, 3. Hmm. Wait, this... Nothing should be including the strings module, so I'm kind of confused why it is. I need to scroll really far out to get to where an operator overload is. Okay. So it seems to just work. That's pretty interesting. Oh, I should also pull up a terminal so I can actually execute this. Okay, so it does still run. That's good. Okay, so that was an easier fix than I actually expected it would be. So let's start implementing structs. Yeah, so right now in the AST, hold on, the music is a little loud. Okay, so basically the AST generates sort of an incomplete thing. It does create a compiler-defined struct, just based off the keyword. But other than that, it's kind of broken. Also, this is actually some really old pseudocode. It would actually be written like this, of course. So I think... Hold on, let me see if that actually is formed correctly. It may not be, because I think just a type on its own does not have a default value yet, even though I want you to be able to do something like this, but I think currently there's only a check for something like this with an actual set operator. Oh, does seem to work actually. Although I don't think this would generate any code. Although it should be pretty easy to do. Struct. Oh, and then codegen. It seems I already have some codegen. generate struct. Although I don't think I really did anything with it. Oh, there's some stuff here. Although obviously it's not generating any actual code, so... I probably want something similar to function ID, but for structs. And I think I can basically have arguments, like argument list, to be members instead. Yeah. And I don't know if I will have some kind of optimizer for uses, but let's just leave that in as well. And then I may have a vector of... should it be function pointers or function IDs? Maybe function IDs, just so that I maintain all of that information. Function ID pointer, probably. And I think that's good. Just copy that entire thing. Name, mingled name, return type, don't need that. And instead of arguments, members. And I don't need the rest of this. I think I have a list, or a vector, yeah. So let's do an unordered map of struct type. Okay. Generate struct. I need to see what the struct actually looks like. Okay, so the token is the name of the struct. So that's correct. And there's the scope body. And then each of these is a member. Okay. So that's an argument list. So I want to do two different checks. One of them is if it's an identifier node, which will just declare the variable, and then one of them if it's a that expression with an equals, then it will get a default value. So it needs to have a child. If it has no children, then let's see. Member declaration must have type, I suppose. Let's see. The member name is just the token value and the member type. It's the child node's token value. Get LVM type from string and then pass in member type. And I'm going to have to modify this get LVM type from string in order to also accept structs by looking up inside of the global struct map. Context, field types. I'm going to need to also add that to the struct type. An arg list is, let's see, the type is a string, the LVM type, the pointer level is reference and must be exact type. Okay. 1492. So I can do M place back. Get AST node type string. Oh, that's right. I need to also convert it to an AST node type. Member type. Pointer level will be. Oh, I guess I have to have pointer handling. This reference is false and must be exact type. That's not relevant. Type node token up first is a pointer. I don't have a mangled name, so that doesn't matter. And after that, I can just do member type is equal to type node token dot first. And also, I forgot that these actually need a first. This actually needs to add to the pointer level as well. Still using that deprecated get pointer to function, but whatever. Okay, so that should be it then. So that gathers all of the members. Now I also need to add this. To the struct definitions. I believe it's struct name followed by struct type pointer. Followed by members. And I forget if that's it. Oh no, there's the mangled name. Let's see. Do I need a mangled name for... I don't believe I need a mangled name for the struct itself, only for the arguments. So I can actually completely remove that. Oops, went a little too far. And... I believe that's it. See if it compiles. It did not. Struct type cannot be used as a function. Oh wait, did I even define the map correctly? I don't think I did. Oh, and also, that's in the wrong order. Yep, unordered map. I didn't give an index value. That would be a string. Oh, that's right. I put struct type above function ID, but it needs to go below it because it relies on it. Compiled. Okay. I didn't use it anywhere, but we should still be able to see if it generated it. And it's not in the output IR. Okay. Oh, that's right. In at the end of here, we don't have any place where we actually generate it. It only generates scope bodies, compile time directives, and functions. But now I also need to have a new case for struct define node, I believe it's called. Okay. And really? Okay, so there still doesn't seem to be a string anywhere. Let's see. Wonder if I can do it like this. Try to build types like that. Okay. I'm not really sure that the generate function is even being called now. I guess let's just add a debug output. And then exit right there. Yeah, so that's not even running. Which is kind of odd because that's... it should be there. Yeah, scope body, identifier type, and it is compiler defined struct. Actually, it should be printing that out. Wait, it's called compiler defined struct. Is that the right one that I'm using? No, I was using struct define node. I don't know why I have two of those. Yeah, that's kind of weird. But now that I'm actually using the correct enum value, it should be generating it. And it exited as it should have. Good. I can remove that now that I know it's actually working. Probably should have already done that so I don't have to recompile 2 times in a row. And it generated, I believe. Okay, it didn't output anything, but there were no errors as well. Or maybe it doesn't output anything to the IR, because I didn't actually use the struct anywhere. Currently, I'm just using this as like a placeholder for the string struct. It just contains one value, int, but obviously, you know, there's this entire one that I've already made. So this is just how it is temporarily. So let's try and use this somewhere then. String s, that's not how I do types. S string. Maybe just like that, or is equal to string. And obviously undefined function. Let's see. I probably want to create a default constructor for every type of struct. Yeah, so let's go to generate struct. Here, well, let's see, what does this IR look like? Or, AST. So it's undefined variable name. That makes sense because it thinks it's an operator. Alright, I'm going to take a 5-minute or so break. I'll be back shortly. Alright, and I'm back. So, just from me scrolling through all of these functions and stuff, I think I've decided to add a quick new feature, and that will be some kind of marker for excluding from the AST output. So basically, inside of the function modifiers, I think I'll do no AST. And that won't actually remove it from, say, the actual code generation, rather just what's actually printed out. Because I don't need to view the AST for all of these built-in functions, as well as anybody else who's using the language. And I will probably leave it in, that is, you know, being able to see the output AST. Just because it may be useful. Alright. Now I want to see what that compiles as, because I'm not sure how the modifier gathering works again. Hold on, this music is getting kind of loud. Alright. Oh, I need to actually compile. Okay, so that'll be down here. And yeah, so inside of compiler modifiers, it's just added. Okay. So 2. I'm going to have some kind of bool called show in AST output. By default, that would be true. But inside of CodeGen, actually no, not. It can't be inside of CodeGen because CodeGen is run after printing the AST, so it has to be inside of parsing. Modifiers node. Alright, so if modifiers, then step through each of the modifiers and see if they are an AST modifier. If m token dot first is equal to, and that would be no AST. Then I'll set the bool, what did I call it? Show an AST output. equal to false. And then now inside of the print AST function, I only want to print the AST if actually that's in the child nodes. Its start node. Okay, I forgot what the name is again. Show an AST output. Show an AST output. If that's false, then just return. All right. So I think that should be working. Nope, that looks kind of like an error somewhere. Show an AST output, 1179. That's right, it has to be node. Oops, still an error. Modifiers node, child nodes. That's what it needs to go through. Okay. All right, now let's see if that worked. So we still have X turns. And then this scope body, this is just the module body. And none of its contents were printed, so that's good. But it still seems to have compiled, at least up to the point where I defined the s:\string. And that's still counted as a leaf node, so I think I need to add that functionality. So for now, I'll just do that. And undefined function, so I need to actually define that. And I think that the way I want to do that is, let's see. To effectively have a function like string, and then maybe have a expression like Something like this. Oh wait, not struct. New string, where this is expected to be a type name. Oh, and yeah, I need to change this right here. So get LVM type from string, that needs to actually return a struct now for if it exists. Yeah. Otherwise, look in struct definitions. Also, I probably want to have better error printing than this. Let's do print token error token could not unknown type. Okay. Instead of having all these exit ones, I'm going to actually have some kind of return or error handling at some point, but I haven't implemented it yet, so else if struct definitions dot find type name is not equal to end, then a type is equal to struct definitions type name dot struct val. I'm not sure how LLVM does that, because currently it's a type pointer, but I'm setting it equal to a struct type pointer, so I'm not sure if those are compatible with each other, or if I have to do some kind of conversion or something. Alright, so now this, I need to actually have a token pair reference. Oh, actually, 0. Actually, it's the wrong one. I want to do child nodes 0 token. That's all of that. And obviously this can't have a default value anymore because I have something after it. Let's just see if that compiles. Oh, sorry, I wasn't looking at chat. Let's see. How do I do research and learn how to develop something like a programming language? Basically, Google and look at documentation. That's pretty much it. In my opinion, I think... Oh, hold on. Console print. That's not a member? Wait, what is it called then? Token... Print token error. Oh, it's just... Yeah, okay, it's not a member of console. As I was saying, I think that the best way to sort of piece everything together is just by working it out for yourself. Like, you can read up on a subject, learn about like individual components, like for example for programming language, what are the steps to go from a piece of text to something that actually executes on your computer. So you can just start like reading about that from start to finish. And even if you don't fully understand it, you can try implementing it yourself. And I mean, maybe you won't get far, but you'll probably learn something. You had a linguistics class that taught AST generation? That's interesting. Oh, I need to create this as a new compile time directive. That's 4. Identifier first is new. I'm not sure if I want to use new as the keyword, because obviously new is for like, well, I mean, I guess that kind of makes sense, because basically what I want to do here is create a piece of allocated memory for a string struct. But typically, I'm pretty sure new should be returning a pointer to the memory. Right now, I'm just implementing the language, like the different parts, starting with, in this stream, I'm working on the structs. I already have, like, I have executing code and everything, but I'm trying to add a little bit of objects to it to make it a little easier. I have, like, C-style strings right now, too, but I don't like those. I like C-sharp style strings. I think C-sharp is probably like one of my favorite languages for strings. But I'm trying to just implement something closer to what a C++ string is, which is a struct of a string. I kind of do both. Like, sometimes I go in blind, sometimes I do some research. For implementing the LLVM backend for this language, I kind of had to do research, because it requires a lot of basically interacting with the LLVM API requires a lot of like book knowledge. You just need to know like the function names, how you want to organize it, and otherwise it just won't work. So you kind of just have to do the research. But for example, the front end of this language, I did zero research for. I just implemented it and it works. And yeah, I got it done way faster than I probably would have if I followed research, or did research and then, you know, just followed it like step by step. But I just implemented it however I thought it should be. It may not be as good or maybe versatile, but it works, so I'm sticking with it. So I need to create a new code gen function for generating a struct instance or type instance. Maybe I'll do type instance because I may generalize this code in the future. Yeah, okay. So let's copy all of that. And I believe I just need to create an aloca expression. Let me add this down here first. Generate call expression. Hi, welcome to the stream. I'm kind of the opinion that many parts of this language should be implementable in the language. Like right now I'm having a lot of, I have a few compiler time expressions or directives, like, you know, new and inline, no AST, cast, things like that. And I think that that's like really important for the language because I don't want it to be limiting. Like if you want to create your entire, like an entire library or something for the language that's in a completely different style and doesn't even look like the language, I think it should be possible for you to do. Even if it's like maybe difficult to do so. I think I just want the language to be like really expandable and really easily as well. Yeah, I said earlier that I'm probably going to make ASA in ASA, but the only issue with that is implementing LLVM. Like, I'd be able to port this code here, the C++, super easily. It basically translates, it translates very well, but it would just like require like some switching around and stuff. And I also don't have like object oriented yet stuff. But the issue will be someone would have to create a translation layer between LLVM and ASA, and that would probably be difficult. Well, not really difficult, but time-consuming. Although, of course, I could create a backend from scratch. I don't want to do that. Yeah, so for Z#, I kind of created that because I had, I wanted to create a programming language, but I didn't really know anything about them. And that's why it turned out so terribly, I'd say. You know, Z# kind of was that language. The programming language that has syntax nothing like C. The problem is that I think C kind of is... It's like the pinnacle of like language development. And I mean, there's a reason why it's sort of stayed up there in terms of usage. I mean, sure, there's a reason that everything is made in C, so obviously you want to keep making things in C, otherwise nothing will be compatible. But it is also kind of just, like, nice. There are some things about it that are, like, not super neat. But, like, a lot of the older programming languages were pretty terrible. Alright, so for the new compiler time directive, that needs to access the first item, which is the scope body, and its child. And then that needs to be the type. Alright, so let's generate the code for that. Wait, child nodes as size. So compile time directive. Child nodes as size needs to be equal to 2. Or child nodes 1, child node size is equal to 0, which would be an empty scope body. Or child nodes 1, child node 0, child nodes is equal to 0. So that last one I don't need. And then it would be like new expression requires struct name or type name. Again, I don't know how much I'm going to generalize this specific keyword. But for now, it's just going to be for structs, because obviously you don't need that for built-in types. Like new type. And then this expression itself will return the aloka. Right now it's not complicated at all. All it does is print out, you know, the bit of text, and it points to the token that caused that error. So it basically just looks like this: error, cast expression, etc. It thinks it's a cast expression right now because I hadn't changed the generator function. But then it just, you know, points to that, and it does nothing else. It doesn't like go back up the call stack or anything like that. And that's just for syntax. It doesn't have I think other than like the LLVM built-in type checks and everything like that, it doesn't really have anything. I'm going to make it better though, someday. And unknown type name used. And that will equal child nodes 1, child node 0. Well, let's see. Still a lot of scrolling, even though I removed these from the AST, but I guess I just have to deal with it. Where am I? Right here. Right, so that's child node 1, 0. Yeah, that's right. 1, 0, token dot first. And instead of find named value, I'll do hold on, it's called struct type. My opinion is kind of that I'm okay with using it as some kind of documentation resource. I've used it a little bit in the creation of this project, just because the LLVM documentation is sometimes really iffy. Especially for the fact that I'm on like the latest version of the main branch. But their documentation is never up to date with that. So it's kind of a mistake that I chose to use the latest version. But something like ChatGPT, it may be able to help guide me in the right direction of how something is implemented in a newer version. So, you know, I'm okay with that much. And I want to do, I first want to see if it's actually inside of struct definitions. So if struct definitions dot find type name is equal to otherwise type val. And I don't believe... I think struct definitions is not... yeah. Its values. So let's get the address of that. And then get struct val. Let's see where I have a loca already. I don't know how to create that. I forget. I think that's... Let's see. I think that's the one I'd want to use. But I thought there was a different... Oh, there is. Create entry block loca is that. Create a loca. Oh, I want to use this one then. I'm not sure what the second value is. Null pointer. Well, I guess I don't need it. 1130? No, 11. No, it's 1322. Generate type instance. Oh, down here. Okay. Loca int pointer is builder create a loca type val struct val. Yeah, okay. And the name of it, what is the name of it? Wait, no, it doesn't get a name. And I think that's it. Oops, I deleted too much. And then I think I just return that itself, but that should be a pointer to the actual thing that's created. It was mostly online resources that I used for AstroSam. I mean, Ben Eater was basically vital to the creation of the AstroSam. I wouldn't have... I think I basically started the project after watching one of his videos on it. Unsupported cast. Yeah, so clearly the error handling is not good in this because it doesn't even print out like a line number. There will not be an Astro 9, but there may be an Astro 16, which is 32-bit. So that happens on 297 cast value, 590. Generate expression statement 933. Is it because that needs to be a string pointer? I guess not. Let's see, 590. Yeah, that's casting. Why is it trying to cast a value though? That's what I'm wondering. 933. I think it's trying to cast this return value, although I'm not entirely sure why. So let's just do that. Still unsupported cast. Okay, so it's not happening there. I thought it was, but it's not. It would have to be happening right here. And I think that's because that's maybe returning a string pointer. Z# doesn't have a backend. It's kind of, it's like weird. It's more like a basically it's interpreted, but it's like not even converted to byte code, if I remember correctly. It basically like operates on the string values themselves. Basically it's terrible. Okay, so that works, just calling it as a function, but then actually setting it here does not. Music is gone, I think. Let's see, did this IR actually output like the string? So there's the, yeah, so here's the function. I mean, that I explicitly define. Obviously this default constructor function would be automatically generated. But then the actual values here are, those are automatically generated. That's surprising though. I didn't think that generating a struct was so explicit. I mean, these are basically like global variables, and it's just adding that. But okay, if that's how they want to do it. So I think new string will then return a pointer to a string, like that. So then I'd have to do that. Still says unsupported cast though, so I think it's doing something with the set expression where it's checking to see if that's actually a default type, and I don't want that. Yeah, generate expression statement 933. So I need to check to see if this is actually a built-in type or not. So if that's not equal to that dot end, I actually want that to be, I want to do another check here to see if it's been defined. And then I can have an else down here, which will say that there's an error because it was not defined. No, it's called struct definitions. Then again, in the cast value function itself, I actually want to have a check as well. If source type is desc type, because right now it throws an error right here, unsupported cast. Oh, so down here it should actually be printing out the types themselves, but it doesn't do that. So that's kind of useless. We'll have a default bool called destination type is a struct. And then if it is, we actually have to look for a function. Let's see. I think I already have code for that somewhere. Not there. Maybe not. I guess I don't. For now, let's just return the value, I guess. And see if that gets us anywhere. I still kind of need to rewrite the type system. It's slowly improving, but still kind of garbage. Call for overload function. Oh wait, is that... Are there more than one cast value functions? Ah, here. Now let's try that. Okay, let's see if that works. Still saying unsupported cast. Okay, did I do that right? Generate expression statement. Oh, here it is. Okay. And if it's a struct, then I want to pass true to that. Still unsupported cast. Okay, that's very weird. The problem, too, is that it's not actually printing out what the types are, so I don't really know what it's receiving. A source signed as true. That's interesting. And is 2 signed as false. So it's 595. Oops. 595. Oh, no, that's where it says unsupported cast. That's on 937. Oh, so it's still odd. Okay. So that means that type name is not correct. Oh, even though it's equal to type node token.first. Oh, wait, hold on. That's because I have string in here. Of course I have string in there. It's not supposed to be in there because that's obviously a struct while all the others are built-in types. That was probably my issue. You know, I think I can just dereference the pointer before passing it back. I didn't really think of that, so the string function is called. I don't need to actually have that as a pointer, I can just dereference this value. Type mismatch and set expression. Really? Really? Okay. Yeah, that is just a string. I don't know where type mismatch that error is from. Down here. Type mismatch and set expression. And for some reason neither of those are printing. So expression val get type. And type. So it should work if I remove this then. They should be equal to each other, but obviously you should be able to also explicitly state the type. Let's just see if this works though. So it calls the string function, and it stores that. Wait, what is it doing? Store string. Okay. And it's allocating both of these. That's the string.0. Okay, so I guess that's just the way that it does it. I mean, it's a little confusing, but alright. And for some reason, I can't do that. But it should be that. So right now I'll just work with inferred types just to verify that this is actually working. Oh wait, I can't verify this is actually working. I need to also implement a new operator, which is the dot operator, so that I can do s dot, for example, c, which is the member. C is an int. So yeah, let's implement that as well. And that's the sample code, I guess. This music is a little distracting. So yeah, of course it says undefined variable name. So I need to create the member access operator. And that's already, yeah, I already have a dot. And that is given the label. So in here then, let's go right here, I guess. Dot will by default have the member access. Not sure if that works. Oh, and dot is already in here. Let's see, what do I even use dot for? I think currently it's only for... let's see. I think it's only for imports. Like that. So let's see what the AST looks like for the imports. Because I don't want to mess that up. Right now it's just a module scope. I hope I don't set that from in here then. It seems not. Okay, that's good. So now it should just be given the type member access. And I just need to add that in. As the code gen. So I'll do if node type is equal to member access, and node code gen is equal to generate member access. Well, that's quite the function to be copying, but whatever. We'll just delete a lot. Member access operation requires left and right arguments. I still want to allow overloading for the dot operator. So I think I'll keep like most of this code here. Otherwise, a regular built-in operator. Member access. And I don't know if I'm going to stick with a dot as the member access operator, but I mean, that's how it is in like every language, so maybe I'll leave it for now. I'm not sure exactly how to access the members, because I think, oh, let's see, I need to actually comment some of this, because I need to look at the IR. Yeah, it just adds a number, like .0. Does it really not have the name? Or did I just forget to include the name? I forget what this is called. Generate type instance, that's right. Or maybe I was looking for generate struct, because that would have the members. Yeah, so it's struct type create, but then I never actually passed the field names. Let me look at the documentation real quick. So it has an array of the types. But not the names, it seems. Yeah, it doesn't seem you can actually pass any member names to the generator. So I'll have to deal with that inside of my own struct type. And we'll set the member name indexes for each of these. Oh wait, that was the wrong one. I wanted that to go in struct definitions. Let's see, what is members? Oh, that's just a vector as well. So let's pass member name indexes. All right. Then my generate member access function. I think I actually need to read up on how this is done because I can get the index, but then I think it's something similar to how I use the bracket access operator for pointers, but like this, but not the exact same. So I think we've been streaming for almost 3 hours now. Let's see, 2 hours, 23 minutes, close enough. So thank you anyone who stuck around this long. I might stream again tomorrow, but in the meantime, I'm just going to be doing some more research on LVM and how to implement structs. Implementing the member functions should actually be really easy. All it would require is generating it as a global normal function and name mingling it, as well as passing probably a reference to the object itself as like a this, but yeah, the member variables I'm going to have to read up on. So thanks everyone for watching, and I'll